November 12, 1942, Richmond, California. On this extraordinary day, a vessel named the SS Robert E. Perryi slipped into the waters of San Francisco Bay, a fully operational Liberty ship. Its journey from bare keel to launch-ready vessel had taken precisely 4 days and 15 hours. To comprehend the sheer audacity of this achievement, one must understand the prevailing reality of naval construction. In an era where the building of a single cargo vessel was an agonizing 6 to 8 month saga of steel and sweat, the Perry's birth was not merely an acceleration, it was a defiant rupture of established industrial dogma. This wasn't merely a faster assembly line, it was a fundamental, almost heretical re-engineering of the very craft of shipbuilding, a radical departure that would turn an ancient trade on its head and fundamentally alter the strategic calculus of the Second World War. By the autumn of 1940, as the Blitzkrieg swept across Europe and the Battle of Britain raged in the skies, a far more insidious and relentless conflict was unfolding beneath the waves of the Atlantic Ocean. This was the Tonnage War, a brutal, existential struggle for the lifelines of the Allied cause, orchestrated by Admiral Karl Dönitz and his burgeoning U-boat fleet. German U-boats, operating in increasingly sophisticated wolf packs, were systematically carving a graveyard out of the vast expanse of the ocean, relentlessly hunting the convoys that were the very arteries of Allied power. The statistics painted a grim picture of impending strategic collapse. In 1940 alone, some 4.3 million tons of Allied shipping vanished beneath the waves, a catastrophic figure that would only escalate. By 1942, over 6.2 million tons of merchant shipping, hundreds of vessels, vital cargo, and thousands of lives would be lost to the predatory efficiency of the German submarine force. Britain, an island nation utterly dependent on maritime supply lines for food, raw materials, and military equipment, teetered on the brink of economic strangulation. The sheer scale of destruction demanded an unprecedented response. Ships had to be built faster than they could be sunk. Yet, the venerable craft of shipbuilding, an industry steeped in centuries of tradition, was fundamentally ill-equipped for such a challenge. The prevailing method for constructing large ocean-going vessels was riveting, a laborious, time-consuming process that was, by its very nature, a strategic bottleneck. Each ship was essentially a complex three-dimensional puzzle, meticulously assembled from thousands of pre-cut steel plates. These plates were then painstakingly joined together by tens of thousands, sometimes hundreds of thousands of individual rivets. This demanded an enormous workforce of highly skilled craftsmen, riveters, holders-on, heaters, and buckers, each performing a specialized, physically demanding task in a symphony of deafening noise and flying sparks. The process was inherently sequential. One section had to be fully riveted before the next could begin, creating an agonizingly slow construction timeline that often stretched to 6, 8, or even 12 months per vessel. Furthermore, the specialized skills required for riveting were not easily or quickly acquired, making skilled labor a scarce and precious commodity. This reliance on traditional methods meant that even with every shipyard operating at maximum capacity, the rate of new ship construction simply could not keep pace with the devastating losses inflicted by the U-boat menace. The gap between what was needed and what could be produced was a chasm growing wider with each sunken vessel. Victory, in the face of such a logistical nightmare, seemed not merely distant but increasingly impossible. In the crucible of this maritime crisis, when traditional methods proved woefully inadequate, a most unlikely figure emerged from the American industrial landscape: Henry J. Kaiser. A construction magnate whose monumental achievements included the Hoover Dam and the Grand Coulee Dam, Kaiser was an outsider to the ancient insular world of shipbuilding. He possessed no intricate knowledge of naval architecture, no pedigree in maritime engineering, yet he arrived with a promise that resonated with the urgency of the hour, a promise so bold it bordered on the audacious: to build ships with unprecedented speed and volume. To the venerable maritime establishment, steeped in centuries of tradition and a meticulous, almost reverential approach to craft, Kaiser's pronouncements were met with a profound, almost visceral skepticism. These were men who had dedicated their lives to the painstaking art of shipbuilding, where every rivet was a testament to strength, every plate a symbol of durability. They viewed Kaiser not as a visionary, but as a brash interloper, an industrialist ignorant of the sea's unforgiving demands. The very notion of constructing vessels at the breakneck pace Kaiser envisioned was deemed not merely ambitious, but fundamentally unsound, a dangerous gamble with the lives of sailors and the strategic integrity of the Allied supply lines. At the heart of this resistance lay the technological chasm between the old guard and Kaiser's radical proposition, the widespread adoption of arc welding. For generations, ships had been riveted together, a laborious process demanding highly skilled craftsmen. Each rivet a point of connection that, while slow to install, was understood and trusted. Welding, by contrast, was a relatively new technique for large-scale construction, particularly for the stresses endured by ocean-going vessels. Traditionalists and naval authorities alike feared that welded joints, especially under the immense strain of heavy seas or combat damage, would prove brittle, leading to catastrophic structural failures. The concept of an entirely welded hull was seen as an untested experiment, an engineering heresy that threatened to send untold numbers of ships and their precious cargo, along with their crews, to the bottom of the Atlantic. The established dogma held firm. Speed could not come at the expense of structural integrity, and welding, they believed, offered neither. Kaiser, the outsider, stood poised against centuries of entrenched expertise, his audacious vision clashing head-on with the very foundations of the maritime world. The venerable shipbuilders, rooted in centuries of tradition, built their titans of the sea with a deafening symphony of rivets. For generations, this was the unassailable method. Steel plates meticulously drilled, aligned with painstaking precision, and then hammered together by teams of specialized laborers. The process was an antiquated ballet of brute force and intricate coordination. Rivet gangs, typically comprising 4 men, worked in a cacophony of industry. One heating the steel pins to cherry red in a portable forge, another catching the searing projectile with a funnel, a third holding the red-hot rivet firmly against the plate, and finally the bucker, who, with a powerful pneumatic hammer, pounded the rivet head flat, forcing the metal to swell and permanently bind the plates. This multi-step, labor-intensive procedure was inherently slow, required immense physical exertion, and left countless tiny gaps, necessitating constant caulking to maintain watertight integrity. Each Liberty ship built this way would have required hundreds of thousands of individual rivets, consuming untold man-hours in a desperate race against the U-boat menace. Kaiser's impossible trick, however, hinged upon a far more elegant yet profoundly controversial technique, arc welding. Where riveting created a mechanical fastening, a series of localized connections between separate pieces of steel, welding achieved a seamless, monolithic bond. An electric arc, superheated to thousands of degrees, melted the edges of the steel plates and a filler metal, fusing them together into a single, continuous structure. This was not a sequence of discrete attachments, but a transformative metallurgical union. The shift was revolutionary. Arc welding drastically reduced the number of steps, eliminating the need for pre-drilled holes, precise alignment of rivets, and the entire noisy, dangerous, and time-consuming process of heating, catching, and bucking. It was a cleaner, quieter, and significantly faster operation, requiring fewer skilled hands. Crucially, welding also slashed the material weight. Riveted holes required overlapping plates and the added mass of countless rivet heads. Welded ships, by contrast, could be built with flush joints, creating a lighter, stronger, and more efficient hull. This reduction in material and labor hours translated directly into unprecedented speed of construction and a radical simplification of the entire shipbuilding process, fundamentally altering the calculus of wartime production and promising a strategic advantage that the traditionalists could scarcely comprehend. The established world of American shipbuilding was a realm of deep-seated tradition, its foundations hammered into place by generations of master craftsmen. At its apex sat figures like Vice Admiral Emory S. Land, a distinguished naval engineer and the formidable head of the U.S. Maritime Commission. Land, a man steeped in the orthodoxy of riveted construction, viewed the nascent technology of arc welding with profound skepticism. To him, the reliability of 1,000 rivets, each meticulously driven and inspected, was a proven certainty. The idea of fusing steel plates with a seemingly flimsy electric spark felt inherently risky, even reckless. This was more than mere personal preference, it was the prevailing dogma of an industry built on empirical lessons learned over centuries. The bureaucratic machinery of the Maritime Commission, under land stewardship, reflected this ingrained conservatism. Change was slow, incremental, and viewed with suspicion, especially when proposed by an outsider like Henry J. Kaiser, a construction magnate with no prior experience in naval architecture. Kaiser's propositions, particularly his insistence on welding as the cornerstone of accelerated production, directly challenged the established order, a direct affront to the very principles that Land and his cadre believed safeguarded the nation's maritime strength. Yet the relentless march of Axis U-boats across the Atlantic began to erode the foundations of this traditionalist resolve. Each sunken Allied vessel was not merely a loss of cargo or life. It represented a widening strategic deficit, a gaping wound in the logistical lifelines sustaining Britain and fueling the eventual Allied counteroffensives. The conventional shipyards, bound by the time-consuming process of riveting, were simply incapable of replacing losses at the required rate. The math was stark. Ships were disappearing beneath the waves far faster than they could be built, threatening to strangle the Allied war effort before it could truly begin. It was against this terrifying backdrop that Kaiser's early, audacious experiments began to yield undeniable, almost miraculous results. While the purists debated the theoretical vulnerabilities of welded seams, Kaiser's burgeoning shipyards, like those at Richmond, California, were demonstrating that mass-produced modular sections, joined by continuous arc welds, could dramatically compress construction schedules. The raw, pragmatic efficiency of these early Liberty ship hulls, rising from the slipways in fractions of the traditional time, began to speak a language even the most hardened traditionalists could not ignore. Vice Admiral Land, confronted by the existential crisis gripping Allied shipping and the irrefutable evidence of Kaiser's burgeoning production rates, found his position untenable. The luxury of theoretical debate had vanished, replaced by the grim imperative of survival. While his personal reservations about the long-term integrity of welded hulls likely persisted, the sheer urgency of the war effort forced a pragmatic capitulation. The unproven became the unavoidable. The U.S. Maritime Commission, under Land's reluctant decree, began to mandate the widespread adoption of welding techniques across all Liberty ship construction programs, a reluctant embrace of a technology that would not only win the war, but fundamentally redefine shipbuilding forever. With the reluctant acceptance of welding's strategic necessity, the U.S. Maritime Commission had opened the gates not just to a new technique, but to a fundamentally reimagined industrial landscape. Henry J. Kaiser, the construction magnate, derided by shipbuilding traditionalists, did not merely adopt welding, he built entire industrial ecosystems around it. He was not just changing how ships were made, but where and by whom. Kaiser's genius lay in his perception of a shipyard not as a static basin where a single vessel slowly coalesced, but as a dynamic, flowing assembly line, an automotive factory scaled to naval proportions. His groundbreaking approach began with the radical redesign of the very concept of a shipbuilding facility. Traditional yards were linear, their slipways serving as the primary construction zones, forcing all work to converge on a single massive hull. This created chronic bottlenecks, with skilled labor often waiting for preceding stages to complete. Kaiser obliterated this paradigm. His yards became vast, sprawling cathedrals of industry, segmented into specialized bays, each humming with simultaneous activity. The core innovation was prefabrication. Instead of constructing a ship section by section directly on the slipway, massive hull components, entire decks, bulkheads, or even complete engine room sections were welded together off-hull in these dedicated specialized workshops. These colossal modules, some weighing hundreds of tons, were crafted in parallel, often miles from the final assembly point. This meant that while one section of a ship was being welded in Bay A, another was being fabricated in Bay B, and yet another in Bay C, transforming a sequential process into a highly efficient parallel operation. Once complete, these gargantuan, pre-welded sections, each a skeletal steel testament to efficient engineering, were not moved by brute force, but by a ballet of heavy machinery. Overhead, monstrous gantry cranes, like mechanical titans, traversed the length and breadth of the yards. With a calculated precision that belied their immense power, these cranes would lift and transport the prefabricated sections, smoothly positioning them onto waiting railway cars or barges. These components were then ferried to the designated slipways, where a further battery of even larger gantry cranes awaited, ready to orchestrate the final assembly. The modular design, therefore, was not merely about welding smaller pieces. It was about the logistical mastery of constructing a ship in massive, interchangeable blocks, each a self-contained unit of progress. This radical shift in production methodology was the logistical linchpin that would soon allow Kaiser to achieve what the traditionalists deemed utterly impossible: shipbuilding on an unprecedented, accelerated timetable. Kaiser's radical reimagining of the shipyard, transforming it from a traditional craft workshop into an assembly line, demanded a workforce utterly different from the skilled artisans of old. The intricate, often dangerous work of riveting, a craft passed down through generations, had created an exclusive guild of labor. But welding, the very technique that underpinned Kaiser's Industrial Revolution, offered a profound social liberation. Riveting, requiring teams of 4, each with specialized roles as heater, catcher, bucker, and driver, was a meticulous, physically demanding ballet. Welding, by stark contrast, could be mastered in a fraction of that time. Where a riveter might spend years honing his trade, a welder could be trained to a sufficient standard for repetitive production line work in a matter of weeks, sometimes even days. This inherent simplicity was not merely an engineering triumph, it was a social catalyst. The traditional male-dominated workforce, already stretched thin by the demands of military conscription, was no longer the sole source of skilled labor. Kaiser's shipyards, and indeed the entire war industry, threw open their gates to an unprecedented influx of workers. Women and minority groups, historically relegated to menial or domestic roles, now stepped onto the industrial stage. The iconic image of Rosie the Riveter, while symbolizing women's entry into factory work, soon found a powerful counterpart in Wendy the Welder. Thousands of women, many of whom had never before held a tool heavier than a kitchen utensil, donned protective gear and picked up welder torches, learning to fuse steel plates with precision and contributing directly to the war effort in a way previously unimaginable. Simultaneously, discriminatory hiring practices that had historically barred African Americans, Hispanic Americans, and other minority groups from well-paying industrial jobs began to crumble under the immense pressure of wartime demand and Kaiser's pragmatic, results-driven ethos. These shipyards became melting pots of America's diverse population, each individual a vital cog in the colossal machinery of war production. The scale of this transformation was staggering. Kaiser established vast, accelerated training programs, turning homemakers, farmers, and clerks into proficient welders, pipe fitters, and crane operators. These were not merely vocational schools. They were crucibles of social change, forging a welder's army that numbered in the hundreds of thousands. The skills acquired, though often specialized for the shipyards, imbued these workers with a new sense of independence, economic power, and national purpose. The minimalist arc weld, therefore, did more than just join steel plates. It welded together a new American workforce, democratizing skilled labor and demonstrating that the latent potential of a nation, once unleashed, could achieve the truly impossible. The theoretical blueprint of expedited construction, forged in the crucible of necessity, now began to manifest as a tangible, escalating reality. The initial predictions of skeptical traditionalists evaporated under the relentless onslaught of practical innovation. What had once been an arduous, multi-month undertaking, averaging a staggering 197 days per vessel across the American maritime industry, was rapidly collapsing under Kaiser's revolutionary paradigm. The first tangible victories were profound. The average construction time at Kaiser's prodigious Oregon Shipbuilding Corporation plummeted from the industry standard to a mere 70 days, an unthinkable acceleration just months prior. This was not an anomaly, but a new baseline, further sharpened by relentless optimization, which soon saw the average drop again to an astonishing 40 days. Each ship launched was a direct repudiation of established dogma, a logistical counterpunch to the U-boat menace, and a visible manifestation of American industrial might. Kaiser, ever the astute motivator, cultivated an intense, almost gladiatorial spirit of competition between his various yards. Challenges were issued, records were pursued with fervent zeal, and the sheer velocity of production became a point of fierce pride and national purpose. This internal rivalry, far from being a distraction, was a critical accelerator. Teams meticulously refined every step of the process. Welding techniques were honed to surgical precision. Prefabrication schedules were tightened to the minute, and the dance of massive cranes swinging pre-assembled sections into place achieved a breathtaking, almost balletic efficiency. The culmination of this accelerating operational tempo arrived with a challenge that captured the nation's imagination: to construct a Liberty ship in an unprecedented 10 days. The objective was not merely to build a vessel, but to shatter psychological barriers and demonstrate the absolute limits of the new methodology. On September 27, 1942, at Kaiser's Oregon Shipbuilding Yard, the keel of the SS Joseph N. Teal was laid. Over the next 10 days, the world watched as a skeleton of steel rapidly clothed itself in plates, bulkheads, and superstructure, propelled by a workforce galvanized by the challenge. On October 7th, the SS Joseph N. Teal slid down the ways, fully complete and ready for sea trials, in precisely 10 days. It was a feat that redefined industrial capability, transforming the velocity of victory from a conceptual aspiration into an undeniable operational reality. The challenge to build a ship, not in months but in days, culminated in the spectacle of the SS Robert E. Perryi. This was not merely an exercise in speed, but a meticulously orchestrated demonstration, a gauntlet thrown down to conventional wisdom. Kaiser's Oregon Shipbuilding Yard transformed into a living, breathing testament to industrial might, where every hour was a battle fought against the ticking clock and the relentless U-boat menace in the Atlantic. The extreme measures taken were unprecedented. Work shifts became a continuous 24-hour cycle, blurring day into night. Thousands of workers, many of them newly trained, moved with a synchronized efficiency that belied their inexperience. The vast expanse of the yard buzzed with a frenetic energy, a symphony of cranes, forklifts, and human endeavor. Crucially, the Perryi's construction pushed the concept of prefabrication to its absolute zenith. Entire sections of the hull, superstructure, and even pre-fitted machinery, colossal components weighing hundreds of tons, arrived at the slipway as fully integrated modules. These weren't just plates of steel, they were vast three-dimensional puzzles, ready to be seamlessly interlocked. The true marvel and the heart of this record-breaking feat was the welding itself. It was a continuous, synchronized effort, an unbroken chain of arc welders working simultaneously across the entire length and breadth of the ship. Teams ascended scaffolding, joining plate to plate, bulkhead to frame, fusing steel with an incandescent brilliance. The rhythmic crackle and flash of electrodes became the drumbeat of progress, as the once disparate sections of the vessel melded into a singular, integrated hull. This was the ultimate showcase of minimalist arc welding's potential, transforming what traditional shipwrights considered a radical, unproven technique into a tangible, world-changing reality. The SS Robert E. Perryi was completed from keel laying to launch in an astonishing 4 days and 15 hours. It was a staggering achievement that didn't just break records, it shattered the very foundations of shipbuilding, proving beyond any doubt that speed, strength, and scale could be achieved simultaneously, fundamentally altering the calculus of Allied industrial capacity and turning a theoretical advantage into a devastating operational reality against the Axis powers. The astonishing feat of the SS Robert E. Perryi, constructed in less than 5 days, was far more than a mere publicity stunt. It was a categorical imperative, an undeniable demonstration of a new industrial paradigm that immediately reverberated through the highest echelons of Allied command. The U.S. Maritime Commission, initially a bastion of traditional shipbuilding practices and skepticism towards Kaiser's unconventional methods, found itself confronted with irrefutable evidence. The sheer scale of U-boat depredations in the Atlantic demanded a radical, immediate response. Thus, the Perryi's record-breaking sprint from keel to launch became the catalyst for an unprecedented decree. Within weeks of her sea trials, the Commission issued a sweeping mandate. Every shipyard engaged in the Liberty Ship program was ordered to adopt Kaiser's revolutionary techniques of extensive prefabrication and minimalist arc welding. This was not a suggestion. It was a non-negotiable directive, a strategic realignment enforced by the exigencies of total war.
For the venerable, traditional shipyards, steeped in generations of rivet-based construction and hierarchical craft unions, this was a bitter pill to swallow. Their engineers and foremen, who had dismissed Kaiser as a mere dirt contractor lacking genuine maritime experience, now faced the humiliating prospect of learning from the very man they had scorned. Resistance was palpable, a quiet defiance born of pride and ingrained methodology. Yet the war effort permitted no room for ideological rigidity. Under immense pressure, these established yards were compelled to dismantle their time-honored practices, reconfigure their layouts, and retrain their workforces in the intricate choreography of modular construction and continuous welding. The transformation was arduous but ultimately successful. Cranes became the new workhorses, lifting colossal pre-outfitted sections into place with precision never before seen. Rivet guns, once the deafening symphony of the shipyards, were largely silenced, replaced by the hissing glow of welding arcs. The industry, once a fragmented collection of individual craft specialties, was streamlined into an assembly line marvel. The results were nothing short of miraculous. Across the entire shipbuilding landscape, the average construction time for a Liberty ship plummeted from Kaiser's initial 105 days, then 70, then the Perryi's 4, to a staggering industry-wide average of just 42 days. This rapid, forced evolution not only redefined American industrial capacity, but established a new global standard for maritime construction, a testament to the brutal efficiency forged in the crucible of conflict. The reverberations of this industrial insurgency, however, extended far beyond the immediate exigencies of wartime shipbuilding. The welded miracle was more than merely a fabrication technique, it was a profound paradigm shift in industrial organization and labor management, a blueprint for efficiency that would reshake the post-war world. Kaiser's genius lay not solely in metallurgy, but in the meticulous choreography of the entire production ecosystem. His shipyards, envisioned not as ancient docks, but as vast assembly lines, perfected the art of prefabrication and modular construction. Massive sections of a ship, complete with wiring and piping, were assembled hundreds of feet from the ways, then hoisted into place by gargantuan cranes, a system that fundamentally challenged the craft-based traditions of industry. This radical reimagining of the workplace, born of wartime exigency, democratized skilled labor, proving that with standardized processes and efficient training, virtually anyone could contribute meaningfully to complex industrial undertakings. It was a stark repudiation of the hierarchical, often exclusionary labor practices that had long dominated heavy industry, opening doors for women and minority groups into skilled trades on an unprecedented scale. The lessons learned in the cacophony of the shipyard found echoes in the post-war industrial boom. Industries from automotive to construction adopted Kaiser's principles of streamlined production, just-in-time delivery, and modular assembly, dramatically increasing output and reducing costs. Moreover, Kaiser's innovative spirit extended to the welfare of his vast workforce. Recognizing the critical link between employee health and productivity, he established comprehensive healthcare programs for his shipyard workers and their families. This pioneering initiative eventually evolved into Kaiser Permanente, a healthcare system that continues to serve millions today, a direct legacy of wartime industrial pragmatism.
The concept of simplified, modular construction, perfected by Kaiser and his engineers, remains an unseen architecture of modern manufacturing. From the standardized components within a smartphone to the prefabricated units of modern skyscrapers, the principles of breaking down complex structures into manageable, interchangeable modules, each independently fabricated and then rapidly assembled, are direct descendants of the Liberty ship revolution. It was a testament to the idea that innovation, driven by necessity and unburdened by dogma, could not only turn the tide of a global conflict, but also fundamentally alter the very fabric of industrial civilization, leaving an indelible mark on how we build, how we work, and even how we care for one another. Yet, even as the Liberty ships surged from the slipways, a shadow of profound concern began to fall across this industrial miracle. For all their revolutionary speed and unparalleled output, these welded behemoths were not without their unseen costs, their moments of terrifying vulnerability. The very innovation that allowed their unprecedented construction also introduced a perilous new phenomenon, brittle fracture. In the frigid, unforgiving waters of the North Atlantic, and even while docked in port, incidents began to accumulate. Hull sections, seemingly without provocation, would tear with alarming suddenness, propagating rapidly across the monolithic steel plates. Some ships split in half, others developed colossal cracks stretching for dozens of feet, compromising their structural integrity in ways traditional riveted vessels rarely experienced. This was not the slow, predictable yielding of metal, but a catastrophic, instantaneous failure, often accompanied by a deafening report, as if the ship itself were screaming in protest. These were the growing pains of a technology scaled to a degree never before conceived. The science of welding large, complex structures from thick steel plating was still nascent, and the immense pressures of wartime production left little room for leisurely theoretical exploration. Early designs, driven by the need for speed and simplicity, often contained inherent stress concentrators, sharp corners, and abrupt changes in section that, under extreme conditions, could initiate these devastating cracks. Compounding the issue was the quality of the steel itself, produced in wartime quantities, and the lack of comprehensive understanding regarding the metallurgical properties of welded joints under varying temperatures and loads. It was a brutal, urgent learning curve, etched in the steel of vital cargo ships and the lives of their crews. However, to cast the Liberty Ship program as a structural failure would be a profound misreading of history. The crisis of brittle fracture, while serious, was met with the same ingenuity and relentless pragmatism that birthed the ships themselves. Extensive research, spearheaded by metallurgists and engineers, rapidly identified the root causes. Design modifications, such as rounded hatch corners, crack arrestor plates, and improved welding sequences were swiftly implemented. Welding techniques were refined, and the understanding of steel's behavior under stress advanced exponentially, forever changing naval architecture and structural engineering. The sheer statistical triumph of the Liberty ships ultimately dwarfed these initial, albeit critical, challenges. Of the staggering 2,710 Liberty ships constructed, only a small fraction suffered catastrophic failures attributable to brittle fracture. The vast majority performed their duties admirably, ferrying the lifeblood of the Allied war effort across submarine-infested oceans. By the war's end, they had transported over 75 million tons of vital cargo, including tanks, planes, food, and ammunition, forming the logistical backbone that sustained the fighting fronts from Europe to the Pacific. Their ubiquitous presence on every major convoy route became a symbol of American industrial might, a tangible manifestation of President Roosevelt's arsenal of democracy.
Indeed, the long-term strength and reliability of the welded design, once refined, proved exceptional. Many Liberty ships continued in commercial service for decades after the war, a testament to their inherent durability and the robustness of the core welding technology. While early incidents rightly provoked anxiety and drove critical advancements, the overall narrative of the Liberty ships is one of overwhelming success. They were the essential workhorses that kept the Allied war machine moving, proving that innovation, even when it faced terrifying, unforeseen challenges, could ultimately adapt, endure, and prevail, irrevocably altering the future of shipbuilding and global logistics. Ultimately, the story of the Liberty ships is not merely a chronicle of wartime production or a technical marvel. It is, profoundly, the philosophical triumph of minimalist welding. This seemingly humble yet revolutionary technical shift became an unsung hero of World War II. While the roar of cannon and the flash of torpedoes dominated the battlefronts, the silent, incandescent arc of welding torches forged the very sinews of Allied victory in the shipyards, providing a ceaseless flow of material that kept the Allied war machine functioning. It represented a fundamental shift in industrial thought, a testament to how practical ingenuity, unburdened by rigid tradition, could shatter entrenched paradigms and redefine what was considered possible. The triumph of arc welding over riveting was more than an engineering victory. It was a testament to adaptability, a defiant answer to the U-boat menace forged in the crucible of innovation. It democratized skilled labor, drawing millions of previously marginalized individuals into the industrial workforce, proving that capacity and capability could be rapidly scaled through streamlined processes and focused training.
It permanently reshaped industrial design, establishing prefabrication and modular construction as foundational principles that would define the post-war manufacturing landscape, influencing everything from bridges to skyscrapers.
More critically, it redefined the very nature of modern warfare, demonstrating with brutal clarity that the logistical and industrial might of a nation, its sheer capacity to produce and replace, could be as decisive as its tactical prowess or the bravery of its fighting men. The simple act of joining two plates of steel with an electric arc became a powerful metaphor for human adaptability, proving that in the crucible of absolute necessity, the most profound transformations often arise from the simplest yet most intelligently applied innovations. The Liberty ship, born of this welded miracle, stands as an enduring monument not just to wartime necessity, but to the boundless capacity of human ingenuity to overcome the impossible, leaving an indelible mark on history that resonates even today.